Thank you, Allison, wherever you are, can't see, and Life Point Christian Church for the opportunity to speak, and thanks to all of you who are sitting here. I didn't expect it to be so divided like left and right. All right, whiplash. But I just wanted to say that I'm privileged to have been invited to speak today. I'm going to try and keep it under 3 hours. 180 pages of notes. But in all seriousness, I don't want to be too dramatic about this, but it seems like maybe the Lord was preparing me for this conference over quite a span of years, because it covers the areas that I have expertise in, which would be nutrition, exercise, and then spiritual faith matters. So I don't take it lightly. I think that this is probably the high point of my speaking, and that includes at A&M and around the country when I work for USDA, because of the subject matter and you all being here. And also, I realize, if we could put up the next slide, what this verse says. It's the spiritual basis for the concept that I'm trying to speak about, is that all of us are to be ministers. Each of you should use whatever gift you have received to serve others, right? As faithful stewards of God's grace in its various forms. If anyone speaks, they should do so as one who speaks the very words of God. If anyone serves, they should do so with the strength God provides, so that in all things God may be praised through Jesus Christ. To him be the glory and the power forever and ever. Amen. 1 Peter 4:10-11. How many people knew that set of verses? All right, some hands went up. If I had said that in Washington, you might have gotten a few hands, I'm not sure. But anyway, what does this verse emphasize? That every believer, that's all of us in this room, has received gifts from above and should use them, how? To serve other people, not to serve yourself. Thereby, you act as a minister of God's grace. That's it, plain and simple. So whether you speak, whether you sing, whether you serve in some capacity, all believers are to use their gifts for the glory of God. Amen. Amen is right. So I'm humbled and privileged, as I say, to be here this morning speaking. And considering the title that was on the previous slide, Unveiling the Connection Between Gene Expression and Lifestyle, it could just as well have been titled, Discovering How to Adopt a Lifestyle That Will Alter Your Gene Expression for the Better. So if you're interested in that, stick with me. And by the way, I tried to come up with a joke about genetics or genes or something. I couldn't get anything. So I went to the internet, and all they had was really bad, terrible, not funny, including this one. Why did the gene cross the street? To get to the other chromosome. There's something in genetics called the gene cross or gene crossing technique. You'd have to know that to even snicker, but it's certainly not really a knee slapper. Next slide. So the outline, I'll try to stick to it. I may not cover all the things that I intended to cover, because I know time just flies by. But
you have an outline in your folder, just the first page.
Oh, good. Okay. Please don't look at it, because then you'll see that I didn't stick to it. Background and introduction to gene expression. We need to know what we're talking about here. Impact of nutrition on gene expression, physical activity, and the value of spiritual strength training. And I'm here to tell you, faith impacts gene expression. And you don't hear about that too often. So we do need a basic understanding to kick things off. Our first topic is going to cover genes, DNA, and epigenetics. So if I could have the next slide. All right, good. So some of you may have heard of the Human Genome Project, and that ran several decades ago. It took a number of years to complete, and the idea was to map all of the genes contained on human chromosomes. So it was really an international effort across the globe, scientists from various countries. And so it actually provided the foundation that was needed to understand epigenetics. So without this taking place, I would have nothing to talk to you about today. So that's why I wanted to mention the Human Genome Project. Human gene sequencing. Next slide. I also wanted to mention, since Allison told me it was okay to do that I've written a book on strength training, and it's called, as you see here, Old Man Muscle, The Older Man's Guide to Building Muscle and Strength Later in Life. And that's me, because I didn't start until I was 65, which is a few years ago, which is terrible. I should have been doing this all my life, like you guys probably have been doing. But you can start late and get to somewhere and get to a positive place in your life in terms of your health. It's not about being a bodybuilder, it's about becoming stronger so that you can get up off the toilet when you're 86 years old. Right? Sorry to put it so bluntly, but I just had my left knee replaced, and getting off the toilet when I came back from the hospital was an ordeal. I can tell you that much. And just during the 5 months now since the operation, you feel how your muscles in that leg had atrophied, even though they had me doing movements from day one, and my wife was very rigorous in getting me to do those exercises. They weren't strength training exercises. So I really missed not being in the gym, and I could tell, and I can still tell, how weak my leg became. And you all know that if you stop training for a couple of weeks, you almost lose all the muscle tone that you built previous to that. The good news is, thanks to muscle memory, it comes back a lot faster than what it's lost. Well, I should say what it took to gain in the first place. But that's a topic for another day. Anyway, I did bring a couple of copies of this. If anyone has a friend, relative that you think they might enjoy reading this book, I shamelessly say it's a book that all men should read. But you know, the information transfers to women as well. So I want to make that clear, as I will on the next slide. Yeah. That's my wife giving a bear hug to Dean Cain, who was the star of Lois and Clark as Superman Clark Kent. And you see he's wincing slightly. Because my wife was my first client who I trained using the Old Man Muscle workout that, aside from the warm-up and the cool-down and stretch, took 10 minutes 3 times a week. I figured everybody has that kind of time. I didn't want a long workout for myself. I hated the thought of lifting weights, for instance. But she did, and I don't know if you can see her arm there. You don't want to arm wrestle her. You don't want to play her in pool. You don't want to play against her in bowling. Nothing. She wins all the time. That's just the way it is. All righty, I'm losing my place. Yeah. So the first question in your handout is, what are the relationships between DNA, genes, and chromosomes? So this next slide is fairly visual, and it covers that information quite nicely. If you can see here that we have a typical body cell on the left, composed of the nucleus in the center and the cytoplasm surrounding the nucleus. You've got the cell membrane covering everything. But inside the nucleus are these chromosomes. And if you look at a specific region of the chromosome, that would be a gene. And then if you look closely at the gene, that's where the DNA is residing. So this is sort of the hierarchy of understanding the relationship between cells, chromosomes, and DNA. Of course, this is the genetic material, right? And everyone has heard of heredity, and most people know only too well what they inherited from their parents, right? Some good things, and then maybe some things that you don't think are so good. But certainly your eye color, your hair color, whether you're going to be tall or short, stocky or thin, things like that, you inherit from both parents. Next slide. Now, regarding DNA as a molecule, it's if you go back to the previous slide, I'm sorry. If you look at it down there, it's not very large there, but this is twisted molecule. And I don't want to get too technical here, but it's composed of base pairs. I remember being exposed to this in high school for the first time, 58 years ago, whenever it was. And I thought, what on earth are they talking about, base pairs? But the base pairs make up the rungs of the ladder, so to speak, that is twisted in the DNA molecule structure. And if you look at this in a textbook or online, the base pairs are abbreviated as A, T, G, and C. And the discovery here of the structure of DNA was important because the specific sequence of the base pairs that make up the genes along the DNA molecule is what generated what you've heard of many times, I'm sure, the genetic code. So scientists were able to understand or crack the genetic code at this point in history. And why that's important is the genetic code contains the instructions for making molecules that determine all of those features and characteristics that you and I possess, including how our bodies develop and function, including how we respond to the environment. So genetics, I should mention, is the study of traits that are passed on from one generation to the other through their genes and their distinct DNA sequences. What do genes do? Genes are the specific sequences of DNA that code for specific proteins. So we're going to talk about mTOR. How many people have heard of mTOR before? All right, it's good that we're going to talk about it. And mTOR is a regulatory protein, enzyme, actually, but there's also an mTOR gene. So it can be confusing if you just step into this area of study and wonder, I don't understand. There's two mTORs? No. There's a gene that makes mTOR. So it does so through the DNA. Okay? So mTOR has its own gene, and the product that is made is the mTOR molecule. I don't know if that's gibberish right now for you, but I wanted to put that out there. So proteins are very important in the body, as I'm sure you all know. Proteins are often enzymes. They can also be hormones. They can be signal molecules, and this type of thought is much more recent in molecular biology. When I was in high school and college, they didn't really talk about signaling molecules. It's a more recent thing. And it turns out that, like the cell up there are all kinds of signaling molecules that interact with that cell, and that the cell sends out its own messages or signals. And this is how we exist and either thrive or don't thrive. So it's really interesting to try to understand all of these different signals that come and go. What activates mTOR, for instance? And why would we care? Because as we'll see, mTOR is an anabolic molecule or enzyme in that it helps, for instance, in muscle tissue, helps you with muscle protein synthesis. So if you're going to strength train, it doesn't matter who you are, your body can't help but respond, adapt, by making your muscle bigger and stronger. Of course, with men, they have a different set of hormones, so the muscles respond in a different way, but women certainly can develop muscle size and strength as well. Absolutely. So anyway, I will talk about mTOR a little bit more in a later slide or two. Also, I think most of you are aware that knowing a little bit about DNA, so I'm trying to do a plug for it, we should know something about our DNA and what it does. It's important, these folks buy these ancestry DNA kits, right, to find out about their heritage. You can even understand, look into your risk for certain diseases that are inherited. I don't want to do that because I don't want to know. I'm just going to try to live a certain way, and then, whatever happens, happens. And it won't be my fault. Or so I tell myself. Just before I go to bed every night, I'm telling myself that, and I fall asleep in 2 seconds. So, genetics. I trained a man who's a veterinarian from Texas A&M. He's a professor, and we have some neat conversations about genetics. He's an expert on bison, and he's found out through his genetic work that there's not a pure bison. This is a buffalo. We often call it buffalo. Properly termed bison. Not a pure bison left in Yellowstone or anywhere in the country.
Wow.
They've all been contaminated with cattle genes. So, yeah, I say wow, you say wow, but the Native Americans don't want to hear that, because the bison is a very special spiritual animal to their culture. So when he publishes research such as that, he's very careful about how he says it, but it is true, so he has to publish the truth. But I just say that because DNA is important. It's important that we know something about DNA, but many people never heard of gene expression or epigenetic rejuvenation. So that's where we're headed with this conversation. And man, time just goes so quickly. So speaking about gene expression, how do you express yourself? Well, probably speaking, for sure. Maybe you're in your writings, maybe in your music or your art, things like that. But how does a gene express itself? That's the question we want to address today. And the process by which genes express themselves is getting the information that is encoded in the gene's DNA to eventually make or synthesize a protein. That's how they express themselves. So there's no music or art, although making a protein might be a form of art, I suppose, because they are pretty magnificent structures and also their function. So I want to go on to the next slide and briefly go through this. This is called the central dogma of molecular biology. You remember that, Elsie? In college, we sat in the same classroom. I was, shooting spitballs at her just to get her attention. It worked. So, the first process is called transcription. The first step in gene expression, maybe I should say it that way, is transcription. And you know that word, you transcribe a letter, so to speak. This is where the DNA sequence of a gene is copied, okay, into a molecule called mRNA. Does anybody know what the M stands for? It's a good messenger. I heard mitochondria, I like that. If we can, we'll talk about mitochondria a little bit later. Maybe not, I don't know. But there's an enzyme then that is going to act on mRNA called mRNA, or actually just RNA polymerase. And what this does is it moves the process along, ultimately to what is called translation. And translation is where the DNA copying, with the help of the messenger RNA, is going to produce a product, a protein. And that's where we need to go. And protein synthesis at this level, okay, this is not muscle protein synthesis, this is protein synthesis in genes as a product. This is the way genes express themselves. That's what I wanted to repeat. And you may have heard about ribosomes, the actual cellular machinery that creates the product and translation is happening with an organelle called the ribosome, which you may have heard of or not. So a polypeptide chain, that's a protein molecule, is eventually formed and it folds in 3 dimensions, and it will function if it's got the proper sequence of genes and the proper shape. Next slide. So I wanted to mention that there are 2 kinds of gene expressions, non-epigenetic and then epigenetic. In the non-epigenetic gene expression, there are regulatory proteins involved in the process called transcription factors. We don't have to really worry about that. But they bind to specific DNA sequences near the gene, what they call promoter or starting region. And they will do something very special, either enhance or inhibit the binding of that RNA polymerase enzyme, and that controls the rate of transcription that we talked about a moment ago. Next slide. Now let's talk about the form of gene expression that we all need to be concerned with, interested in, excited about. Epigenetic gene expression. So this is the deal here. Epigenetic gene expression involves heritable changes in gene activity, meaning proteins that they will produce, express, that are not due to alterations in the DNA sequence of bases. Instead, we have modifications of the DNA. On this slide, they're listed. These are called epigenetic modifications that can happen as a result of lifestyle, and they include something called DNA methylation, acetylation, and histone modification. We don't really have to worry too much about what they're called, but this is known. So if you wanted to learn more about it, these are the terms that you would research, look up. So what these processes actually do will either inhibit, turn off, or activate, turn on gene expression. So I think you're maybe beginning to get an idea that lifestyle is going to cause one or more of these things to happen, and that's how genes either will be promoted or repressed, turned on or turned off. So wouldn't it be nice to be able to turn on youthful genes and turn off aging genes?
Yes.
It's not science fiction, okay? Scientists are searching, just like they did for an obesity gene, which unfortunately there was not just one. There's a plethora of genes. Wouldn't it be nice for scientists to identify the key genes that if you can turn them on through something, some mechanism, you stay young, right? And I'm not suggesting you're going to live forever, but let's just say you have a longer health span. So maybe you live to be 98, but your last day on the planet, you're still pretty vital. And you're walking around, you're able to get up and down the stairs and so forth, lift things, carry things. So those of you who are half my age or even more, this is in your future. That's pretty neat. Let's see. What else can I see? So the epigenetic modifications that we're going to discuss and review in terms of lifestyle are changes that happen to the DNA and also to the proteins that are surrounding DNA, because there are histone proteins, as we see behind me, that are associated with DNA structure and chromatin structure, which is all part of that area of the cell. But the DNA sequence, the genetic code, that isn't changed. Okay? And that's very important that it stays intact. Next. Okay. So this is more of a visual representation, and I show you on the left what a methyl group is. A methyl group is just a functional group. It's atoms that are arranged together in like a little tag that sticks onto a molecule. Okay, so CH3, that's carbon, bonded to 3 hydrogen atoms, that's a methyl group. And it turns out that some processes in the body involve methylation. So adding a methyl group to a molecule, and this has consequences. So when a gene's DNA becomes methylated, it can often switch off the gene. So if there's some lifestyle parameter that somehow causes your DNA to become methylated for a particular gene, and let's not forget, I don't think I mentioned this, the Human Genome Project mapped out a total of 20,000 genes in our chromosomes. So it's not just a dozen or 50, there's a lot of them. And not all the functions are known at all, by far. Okay, there's tons of work left to do. But it is known that on occasion, the methylation of a DNA molecule switches off the gene that it's associated with, and that does what? It prevents it from making proteins. Okay, these proteins can be of all kinds of regulatory, metabolic, and so forth affecting it. It's like putting a lock on a door, preventing it from being opened and closed. Okay, the gene just kind of shuts down. And then there's acetylation. Now that functional group is down at the bottom left. It's a carbon atom double bonded to oxygen and single bonded to another methyl group there, we see. And then that can attach onto a DNA molecule, or especially histone proteins, it turns out. And when the histone proteins become acetylated, just with that little group there, it's not very big, they tend to come away from the DNA structure, because histone proteins like to associate with DNA, but if they become acetylated, that kind of moves them away. They lose their grip, so to speak, on DNA structure, and that makes it easier for the gene to be turned on. Okay, because the tight structure of DNA and histone proteins and so forth, I think they call it a nucleosome, loosens up, sort of unravels. Some of you might remember